Hello, welcome to the Chapter 5 review for Geometry, covering these lessons. We did not cover 5.3 in our class, so we're just doing these 4 lessons from that chapter. So let's get started. It says determine whether the given measures can be the lengths of the sides of a triangle. Write yes or no and explain. So if you're one of my students, one of Mr. Wagner's students, we talked about how you could only really had to check the smallest 2 sides and compare that to the third side. All the other pairs will definitely work out if the 2 smallest work out. So look for the 2 smallest sides in each case. In this one, that would be 10.4 and 12.4. In this one, it's going to be 6 and 8. So we just need to check and make sure those 2 add up to be bigger than the third. 10.4 plus 12.4, that's going to be 22.8. And that is not greater than the third side, 23.3. So if the 2 smallest sides don't add up to be bigger than the third side, you cannot make a triangle based on that. So this could be your, at least an equation explanation, right? Yes or no and explain. So let's give a little more verbal explanation beyond that. So this one, no. You could say something like this. The 2 smallest sides don't add up. Or you could say the sum of the 2 smallest sides. So the 2 smallest sides don't add up to be greater than the third side. So this one, a no because of that. If we look at this one, the 2 smallest sides, 6 plus 8, that equals 14, and 14 is definitely greater than the third side, 10. So this one, yes, you could make a triangle based on the same reasoning. So yes. And this one you would say the 2 small sides do add up to be greater than the third. So that is our explanation. The 2 smallest sides do add up to be greater than the third side. Number 2 is done. Number 3, name a median. So a median is going to connect a midpoint to an opposite vertex. So the median, or an example of a median on this one, the only midpoint we have for sure here because of this and this mark would be K. And so K, and connecting to the opposite vertex would be B. So KB or BK, you could say that either way. That's going to be that segment. It looks like A is a point on this line, actually, on AC. So K is that point right there. So we would have to say BK, or you could say KB. Name an angle bisector. So we're looking for angle marks that are definitely congruent. That's down here. So we have to say E, and we could say P is part of that ray or on that ray. So you could say EP, segment EP, and ray EP would be acceptable as well. We could say segment PE, but we cannot say ray PE because that's going to go this other way. So name an altitude now. An altitude, for this, we look at the picture. We're looking for perpendicular marks, and we're looking for a height, basically. So we're looking for perpendicular marks, but it has to be connecting perpendicular to the opposite vertex. This angle is close, but the actual perpendicular line is AC, so that's not connecting to the opposite vertex. A or KB does, but that's not 90 degrees right there. That's a little more than 90 from here to this line right here instead of to this line. So right here we have a point R that's perpendicular right there, this segment to that, and it connects to the opposite vertex. So that is an example of an altitude. That would be, you could say SR or RS. And name a perpendicular bisector. So we're looking for perpendicular measurements, but it has to cut the line or segment, I should say, the segment of the triangle in half. So this one is perpendicular, but it doesn't bisect. BR is not congruent to RE. However, down here, SA, or SK, excuse me, is congruent to KE. And then line AC right here is actually going to be perpendicular as well. So you could say CA, or you could say CK. I would accept either one of those here, CA or CK. And again, you can switch the order of those letters. So you could say AC, and you could say KC. Number 7, sketch the line or line segment and the triangles below. Make the appropriate markings, then name the point of concurrency for each. So I'm going to do this. You should be doing this as precisely as you can. I'm going to show you the idea just to save a little time on the video here and show you how it works, but you should be measuring precisely with rulers, with protractors, things like that. So the median, you're going to find the midpoint. So you'd measure this side, find halfway there. Looks like that would be right about there. So you should measure that and verify that. And midpoint here, you'd make a midpoint mark there approximately, and the midpoint here looks like that'll be right about here. Angle bisectors. Let me bust out this tool here. Let's finish the median one up. So I'm going to draw these medians in red. So it's connecting the midpoint to the opposite vertex, midpoint to the opposite vertex, midpoint to the opposite vertex. And to show that it's a median, you're supposed to make the appropriate markings here. We could say that this is congruent to this one is congruent to this one, and this one is congruent to this one. And right there, they all have that same point of concurrency. They all meet at the same point right here. We would call that one, the name of the point is on this one. You've got that phrase, if it helps you remember, peanut butter can always be in my cookies and Oreos. So peanut butter can always be in my cookies and Oreos. This is perpendicular bisectors is a circumcenter, angle bisectors is an incenter, medians is a centroid, and altitudes is the orthocenter. So medians, centroid would be the name of that point right there. So the centroid is right there. The angle bisector, if you just look over here, I'll just write that down while I'm thinking about it. That's going to be the incenter. Perpendicular bisectors, that's the circumcenter. And altitude, that is the orthocenter. So if you're one of my students, probably talked about where I came up with that on the Appalachian Trail. I was just hungry all the time. Peanut butter can always be in my cookies and Oreos. I would slap some peanut butter, slather some peanut butter on cookies, on Oreos, whatever I could put peanut butter on to make it taste good and get more calories in me. Angle bisector, though, we're going to cut the angles in half. So I'm going to estimate it here again just to save some time in the video. But you should measure this angle and then make sure whatever that measurement is, divide it by 2, and then come up with this sort of thing. So angle bisector, I'm doing my best just to estimate it, but you, again, should be measuring it. So we'd have that angle bisector looks like about right there is going to cut that in half. And then this one, cut this angle in half, looks like right about there. So if you do that correctly, it should all meet at the same point. On this one, this is the point right there that we're going to call the incenter. And to show the appropriate markings, I would want to have something like this. So angle bisector, you need to show that the angles here are congruent, the angles here are congruent, and the angles here are congruent as well. So I'm using different number of markings or of angle markings because these angles aren't necessarily congruent to these ones. This is not the midpoints necessarily either, so I can't make a mark there or a mark there. Perpendicular bisector, we are going to find the midpoints. We got to bisect the lines. So midpoints still be in the same place. You'd take those measurements and then cut those measurements in half. And then we're going to make perpendicular lines with respect to those midpoints, going through those midpoints. So in this one, draw that a little better there. So perpendicular bisector would have something like that here. This one's got to be perpendicular, so I got to measure that, make sure that's actually 90 degrees. I'm a little bit off there, so let me just draw that and I'll move it over. So that is 90 degrees right there, and it's bisecting it. And then finally, we've got right about there, we'd have our third perpendicular bisector. Didn't want to move the whole picture. Let me just grab that. There we go. So this point in this case is the circumcenter right there, where they all come together. So circumcenter is right there, and you have to show that it actually is what it is. So you'd be making markings on your picture, something like this. You got to show that it's perpendicular. and so boxes in the corner, and that it's a bisector. So these are congruent, these two are congruent, and these two segments are congruent. For an altitude, do something similar to that, but now it's got to connect not to the, or not going through the midpoint necessarily, but making sure it's perpendicular and connecting to the opposite vertex here. So if we do this one, let's do something like this. So connect it to the opposite vertex, but then it's got to be perpendicular to that opposite side across from it. So that's got to be a right angle there. If we take this one and go to the opposite side, the altitude would look something like that. It's got to be right at 90 degrees, so you would measure that, make that precise. And this one, make sure that's at 90 degrees, and that looks good right there. So we got a 90-degree measurement right there as well. And make a little box in the corner here, make a box in the corner there and there. Not necessarily connecting midpoints at all, just altitude. So it's just connecting opposite vertex to opposite side in a perpendicular fashion. And this point right here where they all meet is called the orthocenter. Number 8, we're using the diagram. ZC is an altitude. So this is CZC right here. It's an altitude, it says, so I'm going to make that marking in my picture for this one. It says that angle WZC, which is going to be this angle right here. If you connect those dots, it's that angle, WCZ, or ZC is 13x, and CYW, so CYW is, that's this one, that's 5x plus 18. And we're supposed to find the measure of WZC. So this one, WCZ, is going to be this angle up here, the 13x one. So we need to find x based on that information. If this is 90 that way, it's got to be 90 this way as well. And then we have a little triangle right here. Those three angles have to add up to 180 if it's a triangle. So you could say 13x plus 5x plus 18 equals 180, and solve that for x. You've got 18x plus 18 equals 180. You subtract 18 from both sides, you're left with, that'd be 162. And if you divide by 18, you've got x equals, if I would have divided 180 by 18, I would have had 10. So this is going to be 1 less than that since we subtracted an 18. So we'd have x equals 9 right there. So we use that information, we plug that in right here, and we'd say the measure of WZC would be 13 times 9, and 13 times 9, that'd be 90 plus 27, so 117 degrees right there for that angle. And I just realized I forgot something. What did I forget? Forgot the 90 in front here. I've got 90, this one plus this one is 180. So I could say, if I could add 118, this would actually be 72. So I got to fix this here. Sometimes that happens. Sometimes I make mistakes, especially with the videos. It's just like the pressure's on. You can't make a mistake here. So if you subtract 90 from both sides, you'd have that. You subtract 18, then you're going to have 72. This would be 4 then. What the heck just happened there? I'm not sure what happened there. So that'd be 4. And you plug in 4, 3 times 4 would be 52 degrees. So that's what we want on this one. Alright, so let's see on this other one what we got going on. If it says XW is an angle bisector, we would say that this is congruent to that. WZX, the whole thing now, I'm going to erase what was here before and use the new information. So WZX, the whole thing right there is going to be, that angle is 8x plus 19. XWZ, XWZ, this one right there, says that's 89 degrees. So not quite 90, even though it looks like it might be. And ZXW, so Z to X to W, that's this angle right here. That is 6x minus 12. So we're supposed to find the measure of WZX WXY is going to be, looks like W to X to Y is going to be this one right here, the orange angle right here. So if I know this one, I'm going to know what this one is, because this one is congruent to this one based on them being, or based on this being WX, an angle bisector. So from there, it looks like I have the same sort of idea going on. I can add these three together to get 180, and then I'll know X from there. So if I have 89 plus 8x plus 19 plus 6x minus 12, that's got to equal 180. And combined like terms, I would have 14x, 89 plus 19, looks like that's going to be 118. 118 minus 12 is going to be 106. If you subtract 106 from both sides, you are left with 74. 84, excuse me. I think I messed something up here. This should have been not 106, but 96. 90, that'd be 108. Yeah, 108 minus 12, that should be 96. My bad there. So 96, subtract 96, and you're left with, yeah, 84. And if you divide both sides by 14, you're left with x equals 6. So take this then and plug it in into here. If you find the measure of, that is angle ZXW, that equals 6x minus 12, and we also know that equals WXY based on the information given to us. So if we have 6 times 6 minus 12, that's going to equal the measure of WXY, and that would be 36 minus 12, which would be 24 degrees right there. So 24 degrees, that's your final answer for the measure of angle WXY. Number 10, if G is the centroid of ABC, if it's a centroid, we know that it's in that 1 to 2 ratio. You can think of the bigger part being 2/3 of the whole thing. That's another way to think of it. AE is 24. So AE all the way from A to E is 24, we're saying in this one. DG is 5, so that is 5 from here to here. And CG from here to here, C to G, that is 14. We're supposed to find DB in this case. So we really have a lot of extra information that we don't need on this one. You don't actually need to know that this is 24, so I'm just going to erase that. You don't actually need to know that that's 14. It's true in the picture based on the information, but we're just focusing on this. If we're going to find DB, all we need to know is this one. And it's in that 2 to 1 ratio. So if this is 9, or this is 5, excuse me, this bigger part of that median, this is a smaller part, it's twice as smaller, it's half as big as this part. So this would be 10 right here. GB would be 10. And we know that DB is the sum of DG plus GB. So you'd have 5 plus 10 on this one, that's going to be 15. If you want to use that 2/3 equation that you have in the book, go ahead, be my guest. But I prefer thinking of it in a 2 to 1 ratio way. I think it's just a little easier to think about that way. Number 11, determine the relationship between the lengths of UD and YS. So UD is right here. So let's just darken that in. So UD and YS, that's this one right here. So on this one, let's start by filling in the angle measures that are missing. We might find that to be helpful. So if this is 111 right here, this one you do 180 minus that, and you'd have 69 degrees for that one. If this is 69, that's 35. If you add those two up and subtract that from 180, we're going to have 76 for that one right there. And do the same sort of thing with this one and this one. Add those two up and subtract that from 180. You're going to end up with another 69 degree measurement right there. And do the same thing with this one. Or you could just take this one and subtract 180 from that. You'd be left with, looks like 102 degrees. And I gotta be frank with you on this one. I'm not seeing it. I'm not seeing how I can prove this is true. Clearly it looks like UD is less than SY or YS. But to actually prove that, I think I'm going to have to go back later in this video and just add a comment in there or add a speech bubble, something like that, explaining why it is, if I end up figuring out why that is. But based on the things we've learned, it's probably easy to prove, and I'm just not seeing it, but I need to keep going on this video here. We can assume that this is true, and I'll have to get back to you, or I'll have to add something into the picture later as to why that is. So UD is less than YS, or you could say that YS is greater than UD. The lengths of their sides are like that. So I'll get back to you on that one later. Number 12 here, determine the relationship between the measures of EQU and AEQ. So EQU, that is this angle right here. Connect E to Q to U, you get that angle. AEQ is this whole angle right here, AEQ. So if we look at the whole triangle, the big triangle here, we've got 8 right there, and then we have 3 plus 7 for the side across from that angle. That's going to be 10 right there. So 3 plus 7, this whole length AQ would equal 10. So if you look at the sides, 10 and 8, the one that's bigger is 10, and that's across from this angle right there. So what's the relationship? This angle has to be a little bit bigger than that angle, since this number is bigger than that number. We could say then that the measure of angle AEQ is greater than the measure of angle EQU. So you can say that, or you can flip that around and say the measure of angle EQU is less than the measure of angle AEQ. If we look at number 13, list the angles, that really should say, of angle, or of triangle GHI in order from least to greatest measure. If we look at the sides across from the angles, 9.6 is going to be the top dog. That's the biggest one right there. And then 8 is this second biggest. That's across from I. And then finally 7 is across from angle H. So if we put them in order, we'd go blue to red to green. We would have the measure of angle, and since it's clear what G is referred to, I can just use one letter here. The measure of angle G is going to be greater than the measure of angle I, which is going to be greater than the measure of angle H. And you could flip the order of that, and I just wrote them in the wrong direction there. So it says least to greatest. I would want to switch those around. So let's put them in the correct order. We would have H first is less than, and then you'd have I next, and then finally you'd have G after that. So H to I to G going in least to greatest order right there. List the sides of triangle PQR from shortest to longest. So look at the angles. 80 is the biggest. That's going to be the longest. We're looking for the shortest though. The shortest would be 45, which is across from QR. So we could say QR is going to be the shortest. And then after that, 55 comes next. That's across from QP or PQ. So QR, shortest to longest, would be less than QP, which would be less than PR. And that would be our correct statement there. Moving on from there, then the longest segment in this figure below. If we look at the angle measures, we could fill in the other missing measurements here. If you do 180 minus these two, you're going to end up getting 63 degrees right here. If you do 180 minus these two, you'll get that measurement. You'll have 53 degrees right there. So if we look at all that information in the picture, the longest segment in the figure, well, we have in this triangle, this smaller triangle, the one that would be the biggest in this triangle would have to be across from the biggest angle. So AH would be the biggest in this blue triangle right here. So we would say AH in that smaller triangle is the biggest. However, if we look at the other triangle, in that triangle, that has to be the smallest because it's across from the smallest angle. So this one might be the biggest in this triangle, but it gets trumped in this one because that's got to be the smallest in this triangle. And so this one actually here is the biggest angle in this triangle. I'll call it the purple triangle. So then the purple triangle, that angle is the biggest. It's across from that side. So this one we would say MH. By the explanation I just had there, MH has to be the segment that is the longest in that figure. So if we look at number 16 now, draw the shortest distance between P to NT. The shortest distance between a point and a line is always the perpendicular distance between those two things. It's the altitude connecting those two things. So we would simply draw in something that looks like this. So connect that point. It can't be like this, can't be like this. It's got to be perfectly perpendicular to that. So and then just to show that, you draw a little box in the corner, you'd be good to go. For number 17, write and solve an inequality to find x. So it looks like here we've got this side angle side type relationship that we need. We have a congruent side here and here, even though it doesn't look like necessarily that's congruent to that. We're going to make that assumption because that's information in the picture. We've got in both triangles, they're sharing this side, so this is congruent in both triangles. So we look at the angle in between them and compare it here to here. This one's bigger, so this side has to be bigger. This side, this angle is smaller, that angle's got to be smaller. So we could say that 3x minus 2 has to be the bigger side. It's got to be greater than that side right there, greater than 10. If you add 2, divide by 3, you're going to get x is not equal to, but x is greater than 4. So that's one piece of what we need. However, we should also check and see what happens when this is just greater than 0. It's got to be a positive length. If it has any measurement at all, we would say 3x minus 2 is greater than 0. You can add 2 to both sides and then divide by 3. You've got x is greater than 2/3. So if those two things are happening at the same time, x is both greater than 2/3 and greater than 4. If you were to draw a number line, if you say this is 0, 1, 2, 3, 4, 2/3 is going to be right about here. So that's going that way, and then 4 is going to be here, going that way. If both of these have to be true at the same time, it's got to be true that the red part is what's happening. Because to both be true at the same time, if x was 3, it would be greater than 2/3, but it would not be greater than 4. Both have to be true at the same time. So this part doesn't work for this inequality. We don't have a compound inequality then. We just have this part, this portion right here. X is greater than 4. So that's your final answer on that one. Number 18, write an inequality comparing the measure of angle 1 to the measure of angle 2. Well, we have congruent portions, parts of the triangle here, and also here they share that side. So if we look at the side across from 1, that's bigger than the side across from angle 2. So if that's bigger, that means 1, the angle itself, has to be greater than 2. So you could say that, or you could flip that around and say the measure of angle 2 is less than the measure of angle 1. For 19, if two sides of a triangle are 24 meters long and 29 meters long, then the third side must have a length between what two measures. So this is the one where and I prefer to write the bigger one first. I add the two sides, and it's going to be 53. Then I subtract the two sides. It's going to be 24. So if you imagine those two sides of that length connected with a little hinge of sorts, you could open it wide up and it could get all the way to 53 if you had it perfectly flat. If you made it perfectly flat going the other way, you close it up, it could go all the way to 5. To have a triangle though, it's got to be just a little bit, just a skosh bigger than 5 and just a skosh less than 53. And you could say x is the length of the third side. So I'll say let x equal the length of the third side. Then you would say that x is in between 5 and 53. So that would be your answer on that one. If we look at which on yours is the last page, number 20, S, T, and U are perpendicular bisectors of triangle FGH, and they meet at J. So J, if they're perpendicular bisectors, that's peanut butter can, that's the circumcenter right there. If they're perpendicular bisectors, we can also put these sort of markings in the picture. So that's congruent to that, and also we got perpendicular there. This one's congruent to this one. And JG, so from J to G is 4x plus 4. I'm going to draw that in the picture here. So this is 4x plus 4. JH, that is 3y minus 4. HI, this from here to here, HI, I do that, I'll do that in purple. So H to I, that's not purple. From here to here, that we're saying is 4z minus 3. And JF, so from J to F, that is going to be 8. So I'll do that one in red again. JF from here to here is going to be 8. So something we touched on in class was that you can actually circumscribe a circle if that's the circumcenter when you're dealing with perpendicular bisectors. This is a pretty rough circle here, but that's the idea of why this will work this way. We know that this, and this segment all have to be congruent to each other because they're all different radii of that circumscribed circle. So we could say on this one, we could set up an equation 4x plus 4 would equal 8. So from there you've got 4x equals 4 and divide by 4, x equals 1 from there. So if you use that information, we should be able to find y and z from there as well. So y, 3y minus 4 equals, well, that's got to equal 8 as well. So you can add 4 to both sides and divide by 3. You've got y equals 4. And then finally for z, if you know that this one is what it is, do we know any other information in this picture? Let's see what we got here. I see why I was wondering what it was right there. I was covering that up with my marking. So that's 9 right there. If this is 9 and this is congruent to that, which is HI, HI is congruent to IF, we could say that HI equals IF, and then based on the picture you see, the information in the picture, 4z minus 3 would have to equal 9. You add 3 to both sides and divide by 4, you've got z equals 3. And then finally, number 21, the vertices of triangle LMN are, L is at 1, 3. So you've got a mark right there, and then you got M at 4, 0 right there, N is at negative 4, 1 right there. So let me label these. This is L at 1, 3. This is M at 4, 0. And this is N at negative 4, 1. Connect those to make a nice triangle. Try to be as precise as I can here. Okay, so we've got this triangle. We've graphed the triangle. And then it says LG is a median of the triangle. So if it's LG, it has to have L in it. So G's got to be across from that there. We would have to find the midpoint here of this side to know where that extra point is for the median, where G is. So G is going to be the midpoint of NM. So we'd say the midpoint of NM, that's going to be what G is, and that's going to be the average of the x's, so x1 plus x2 over 2, and the average of the y's for NM, for that particular segment. So we would have, looks like -4 plus 4. And we would also have 1 plus 0. That's going to equal, looks like 0 over 2 and 1 over 2. So the coordinates of G would be 0 and 1/2 or 0.5. So G's coordinates 0 and 1/2. And then graph median LG on the same graph, pretty simple to do from there. You've got 0 and 1/2, that's that point right there, and then just connect them. Connect L to G. And I'll just label that as G being at 0, 1/2, and we're good to go right there. So that'll do it for us for this review. Again, I'll try to go back and add comments to number 11 if I happen to figure that out. Sometimes you just don't see it and you have to think about it for a while. Just for the sake of the time of the video, I don't want you to just sit there and wonder what I'm thinking. So I'll come in, fill in some information there later if you happen to figure that out. But go back, review, and hope you do well on the test if you're one of my students. If you have any comments, questions, let me know. Have a great day.